Hello humans, we are working on Principles of Matter 2.1 through 2.3. This is about density of solids, liquids, and gases. Remember the three phases of matter are solid, liquid, and gas for our purposes. There's another one, but we don't get to see it in the classroom. It's called plasma. That's what stars are made out of. So in 2.1, we found the density of liquid water using a balance in a graduated cylinder. You used a graduated cylinder to find the volume of a liquid. So the volume would go on the underside of this simple calculation. Density equals mass divided by volume. The volume in this case was measured in milliliters. Then we took a scale, which our textbook calls a balance, and we used it to find the mass. And remember, if you're using this as a balance, we need to measure in grams. There's a little arrow there pointing at grams. If you use another unit, our calculation doesn't function. So we got the mass of the water and the graduated cylinder, and we recorded that. We'll look at an example on the board. We took that same cylinder, dumped the water out, and got the empty mass. We subtracted the two to find the mass of the water. And so here's one example. This is not the exact example we just looked at, but we record the value of the empty graduated cylinder, and it really doesn't matter what order we go in. As long as we get the empty graduated cylinder's mass, we know this is mass because of, we've got the unit grams there. The volume of the water we measured is 84 milliliters, and then the water plus the cylinder mass was 124 grams. Now, we've got a set of parentheses here, and we're going to do this first because what that's doing is that is subtracting the empty cylinder, or the tare weight of the container, from the water and cylinder. And that's going to give us, once we subtract those, that gives us the mass of the water. And there's a decimal there. That's 83.3 in this particular example. So we got 83.3 grams of liquid water divided by how many milliliters of volume it took up. And our arithmetic shows us that this number divided by this number is 0.99 grams per milliliter. Every group that did this lab correctly got a number that was very close to 1 and will at least round to 1 gram per milliliter, because that is the density of water. We also had a brief discussion about how to look at the graduations on our graduated cylinders, and if you have a line of water that's directly in the middle, you would estimate that at 68.5. If it's closer to the top, you might say 68.7 or 68.8. You do have to estimate that last digit. All right, let's take a look at what's going to happen in the next lab. So the next lab, we still need our balance, but you're going to use a different method to find the volume of rectangular solids. And what you're going to do is you're going to take your ruler and just a moment, look at how our balance has drifted a little bit. If it drifts, you hit the tare and it'll reset. All right, so I'm going to scoot this up a little bit. So you're going to take a block. We've got the white plastic block, the transparent or translucent plastic block, a block of aluminum, which is shiny and metallic, and then there's a block of wax, which is not a perfect block. You'll notice the shape is not perfect, and I'm going to let your group decide exactly how you'll find the volume of that one. But the method is this. You'll take your ruler, and we have to use centimeters for our formulas to work. And so, for example, let's see if we can get close enough to this. Do you see how the last graduation on the ruler, not the end of the ruler, but the last graduation has to be lined up with the block? And this block is 2 centimeters in that orientation. And remember, we have to pick a corner and measure all 3 sides that touch that corner. Let's check this other edge. Remember, the graduation has to be lined up on the edge of the plastic. So this direction is 5 centimeters, and then we have to check the other edge that touches that corner. And this edge is 5 centimeters. So we have length times width times height, or you can rearrange that. You can say this is width and height and length, as long as you get all 3 edges that touch a corner. That's the method for measuring these blocks. Same method for each one. On your paper, make sure that you write down white plastic block, clear plastic block, aluminum block, and wax block. So there's 4 calculations. You'll do the length times width times the height, and that's going to give you a volume in centimeters cubed. So our formula is going to be the same. Let's go back up here. Density equals mass divided by volume. So if you made your measurements in centimeters, you'll be able to calculate the volume. Then you'll have to find the mass, put it on the balance. Make sure you record on your paper, say, mass of white plastic block. And then you're going to plug in the formula, density equals mass divided by volume. And your answer is going to come out in grams per, well, if we were using the graduated cylinder, it would be milliliters. But since we're measuring with a ruler, it'll be centimeters cubed. And remember, we said over and over on Monday that 1 milliliter and 1 gram per cubic, 1 milliliter and 1 cubic centimeter are exactly the same amount of volume. So you'll be using your rulers for these. All right, let's move those out of the way. The next activity, you'll be, actually it may be part of that one, you need to find the volume of this copper cylinder. So a kid in second period the other day said, hey, we got to find the base times height. So the base on this, and remember, we got the graduation on the edge. This looks like 1.2 centimeters diameter. And the height on this one appears to be, I can't really see that through the camera, 4.5 once everything gets lined up, 4.5 centimeters. So the formula for that will be, and we'll put this on your paper, but the formula for that will be pi r squared times height. And your volume for this, again, is going to be in centimeters cubed. You'll put it on the balance to get the mass, and then you will plug that very same data into the same formula, density equals mass divided by volume. The same formula for density is used every time we find density. All right, and now for the fun ones. Actually, those are all fun. So we have some irregularly shaped object. The book calls this a steel bolt. And we have another thing called a nylon spacer. And a nylon spacer is a cylinder with a cylinder-shaped hole in it. And we could measure this one and calculate the volume. If you and your group feel advanced enough to do that, you go ahead. There's another way to do this, though. And one way to do this is you use a graduated cylinder. In this case, you'll probably want to put about 70 mils, it doesn't have to be exactly. And what you're going to do is very carefully, don't just drop this in, it'll crack the bottom, but slide this in. And when you slide the bolt into the water displacement moves upward. And if you find the difference between the first value and the second value, the amount that the water changes is the volume of the bolt. And then, of course, and I'm not going to take it out of here right now because I'll make a mess, then you're going to get the mass of the bolt. You'll use the difference to get the volume, and you will once again plug in the formula. Let's say it together. Density equals mass divided by volume. Let's get to work.